I would like to welcome our speakers for today, Dr. Bharat Kale, Director General, Center for Materials for Electronic Technology, Pune, CMET. Dr. Sandeep Chatterjee, who has joined us online. He is the Group Coordinator and Director from METI, Government of India, New Delhi. Dr. Ratish, who has also joined online, is the Director of CMET, Hyderabad. Dr. N. Raghu, who is the Director of CMET, Thrissur. Dr. Rajendra Kumar Sharma, who is here in the MCCIA, and my colleague Sri Krishna Gadgir, who will be joining us in a few minutes. So, two small announcements before we start. First is keep your mobiles on silent. And second is that we will be taking the question answers towards the end of the session. So you have notepads with you, whatever questions you have, kindly note down. So all the speakers will be available to answer your queries towards the end of the session. So I would now like to introduce our main speaker for today, Dr. Bharat Kale, Director, CMET, Pune. So Dr. Bharat Kale holds a PhD from CSIR National Chemical Laboratory, Pune. He has over 32 years of versatile research experience in all these areas: nanostructured advanced materials, solar cells, thermoelectric solar cells, lithium and sodium-ion batteries, quantum dots in glasses, and hydrogen storage materials. So he has published papers in over 260 international publications and holds 26 patents, include 4 from the US. He's a recipient of many prestigious national and international awards. 27 research projects have been completed under his leadership. And with this very brief introduction, I would like to request Dr. Kale to give a welcome address. Over to you, sir. Want to use this?
I think that's better. Thank you, Zobek, sir. Thanks a lot for. Actually, we had a discussion with MCCIA, and MCCIA is agreed for at least the to hold this industry academia workshop. I can say workshop, and I'm very happy that our colleagues are also joined today, and I should thank to them and welcome all of you, because we have come for this the workshop, because a lot many things we are doing in our organization, and I think the industry should know that what we are doing in our organizations, and what are the technologies we have developed that we have to tell today, that what kind of technologies we have. Some of the technologies have been transferred, some of the technologies will be ready for the transfer. And since being the head of 3 organizations, 3 institutes, so 3 centers, I would like to we would like to know about other centers also, because they are also doing the good work, and most of the technologies they are also they are ready, and some of the technologies have been transferred. So now I to welcome to all of you, and my colleagues are also there today. Dr. Rani, Dr. Milin, and Dr. Seth, and other colleagues, as well as Dr. Rajendra Sharma is there, and he is also associated with us for the Center of Excellence, which I am going to talk more on my details presentation. So first, we'll like to inaugurate the workshop at the hand of Dr. Chatterjee.
Good evening. to all. So should I press it here?
That's good.
I pressed it.
Now we hear from our Chatterjee sir. Actually, we are the director of our electronics and component division. We are look after our all materials division on 3 officers. Thank you.
Thank you, Dr. Kale. I'm very happy that MCCIA and CMAT has organized a very important workshop today. Actually, if you see the Indians' development for last 7-8 years, where we are from electronics and ICT sectors, our ministry has also taken a very path-breaking step, because the growth of economy, if you see, that is SME and SME sectors. This is the story for every developed economy, and India will also, follow the same path. And if you are talking about these sectors, MSME and SME sectors, where the technology upgradation is the very one of the important paths to actually further untap the business opportunity in the domestic market as well as in a global market. And there are many unseen challenges like technology as well as standard products, so that these sectors can compete their peer groups around the world. So our ministry is typically working on technology upgrading for different local industries. From 2019, we have a ambitious national electronic policy, which was actually highlighted that the R&D supports to the academic institutes should be industry-led. So very challenging, ambition we have taken in that national electronic policy in 2019. And with this aspiration, we have started creating different type of incubation center and center of excellence academic institutes, especially around our own lab, Center of Materials and Electronic Technology. If you see of course, Dr. Kale might be giving a better, the capability and capacity of these labs. But uniqueness of this lab is, you must have found that is a very minuscule engineers and scientists they are having, but the outcome you will see, it is a phenomenal. Because so from the beginning in 1990, we have thought that this lab should be whatever the CSR labs has left, like academic institutes are coming out there bubbling blue sky research. CSR lab actually was trying to upskill those blue sky ideas for a technology and process. So CMAT was concentrating on pilot plant. So in that domain, we have now introduced different technology incubation center in the 3 centers, Hyderabad, Pune, and Thrissur, so that local industry should get the maximum benefits. And all the center of excellence, we have ensured that involvement of the this local industries should be in the main focus. And in that scenario, we have ensured that they should also have some provision to fund their objective and deliverables. So entire project was shaped in such a fashion, it was driven by industry. Then one of the scientists of CMAT we are nurturing that center of excellence, and we are also ensuring that end of this 3 years or 5 years of the center of excellence, it should get a sustainability. So sustainability is focusing due to the that main theme should be nurture for years after our end of the funding support also. And in that scenario, we have taken a very niche area like IoT sensors, 2D graphene materials, electronic waste recycling, additive manufacturing for optoelectronics component. So these are the areas are coming up, and in future also, of course, quantum materials. So these are the areas are very niche areas, and where the country economy will grow. And all those areas are having a highest priority from PMO office and PSA office. So we are actually the CMAT, all the three centers are working on is these niche areas, and where government supports are adequate, I should say. But now I'll be interested to see how this local industries are taking help of these centers and address their initial disabilities and challenges around that centers. So Government of India is very committed, and also will be coming up the new different new areas where I'll be requesting that MCCIA to provide us different problem areas around which we can have more such incubation center. So this is a very good opportunity, and we'll be interested to listen from the different industries. And this type of event, I think I should congratulate CMAT team, Dr. Kale, Dr. Ratish, and Dr. Raghu. So this type of interactions should be very frequent, so that we should also know what are the different pain points. Okay, thank you very much. I'm leaving it here. Then we'll be interested to listen the different problem areas. Thank you, Dr. Kale. Over to you.
Thank you, Dr. Chatterjee. By the way, you must be aware that we are already we have a project with MIT Center for Electronics Common Facility Center, which is taking up shape in our Bosri office. So it will be operational soon, probably in another couple of months.
Good.
So thank you once again, Dr. Chatterjee. I will now request Dr. Kale to give us a brief overview about CMET. My colleagues will just upload the presentation for you.
Thank you.
Thanks to MCCIA for giving us opportunity for the work in the channel we are doing in CMET as well as in other segments. So first of all, I would like to introduce CMET Pune, what CMET Pune is doing, and then our directors, two directors, we present the what are the activities going on in Hyderabad and what kind of technologies they have developed, because they will elaborate in much better way as compared to me, and as well as Dr. Raghu from Trichy, Kerala. So he is also going to talk in technologies, what they have developed in their center. So basically, this is our structure, vision of the CMET. So CMET will become a premier R&D organization known all over the world for its knowledge-based innovation and corporate electronic materials. Basically, R&D in electronic materials and their technologies. Then to develop new materials critical processing technologies become a source of electronic know-how and technical services. Along with these two industry, we are also helping to strategic sector, because they need some very special type of materials. So we work for strategic sectors like ISRO, DRDO, and BRNS or BRC, or you can say that atomic energy. So we have the 3 centers, like Delhi, like Chatterjee's where there we have a common office there. We are interacting with the MIT, so we have office there, and we have in Cement Pune. We have a Cement Pune laboratory, Reactor laboratory in Kerala, and Hyderabad. They have different mandates. So major areas we are working in nanomaterials and devices. Nanomaterials and devices, and nanomaterials devices, integrated electronics packaging, because this is a very most important area for us, which is very important for the strategic sectors. With all kind of electronic packaging, all kind the multi-layer ceramics and all these things we do with the multi-layer packaging. We do in the electronic packaging area, where we have state-of-art facility. We have 2,000 square foot clean room area, and that we have in-house all equipments, the low temperature profile ceramic based electronic packaging. We do that. Then we have ultra high purity materials which we do in Hyderabad, and all kind of semiconductor like germanium and silicon carbide. I can say. Then piezo sensor and actuators with electroceramics. We generally do in Reactor laboratory. All kind of ceramics, all development is going on at Reactor laboratory. Then materials for renewable energy and storage. The energy, we have a solar cell, then fuel cell, then hydrogen generation, then hydrogen storage, then batteries for energy storage and supercapacitor. So all these in the renewable energy and their storage. Then, as Chatterjee mentioned, that we have these additional programs like Center of Excellence, we have rechargeable batteries and technologies. Along with industries, we have 2 industries associated with this. One of them is Spel, Rajendra Sharma. Then additive manufacturing, 3D printing, where we have a lot of scope in at least in electronic components. So we have started that. Then e-waste recycling and management is already going on in Hyderabad, because it has a potential. Because see within a 5-10 years we may have a lot of e-waste. So what to do with this e-waste? So e-waste recycling. Under this e-waste recycling, we have then battery recycling. Then we have the solar panels. Then rare earth magnets recycling. All this we do in Hyderabad. So we have a pilot plan there. So Dr. Ratish will talk on this. Then IoT sensors. See, if you see there is no center of sensors where in one room where the sensor development is going on. Now we have IoT sensor center of excellence in Reactor laboratory, where we can develop all kind of sensors, and most of the industries are associated with this center, so that the sensors can be developed and commercialized. So that is the aim of this center of excellence. Then we have 2 mission programs. We have India Innovation Center for Graphene. So here we are producing graphene and the graphene based devices. This program also is along with industry, Tata Chemicals also we want. Then National Center on Quantum Materials Technology, like quantum computing will come in very fast in the future. So we need the quantum materials. So we have the quantum materials technology program. Under that, we are developing some materials for quantum technology. Next. So this is our summary of achievements. So we have R&D support as well as we are development and towards technology. So all three sectors we are covering. Like we are doing all kind of projects with industry also. There are now 43 projects are running. Along with some of the industry projects also there. Technology transfer, we have 10 technology transfers. Technical services with industry. Already we have 9 industries where we are working with technical services. Then technology ready for transfer. Now we have 19 technologies for transfer apart from the earlier ones. Then technical MOUs we have signed this year, 13. Then there are many awards and recognitions. Now we have 942 publications, papers in international journals within 10 years. And patent we have 145 patent, which also include PCT, World Patent and US Patent. Then we have good program on research program with our students, PhD students working in all areas like I covered, where the physicists are required, then chemists, then metallurgists. So all since this is a multidisciplinary area, so we cover generally take the students of all kind of areas so that we can take from materials to devices. So these are the transport technologies like the recovery of valuable and precious metals from spent printed circuit boards. Then wearable devices for analysis system for the early detection and screening of breast cancer, because this is a project that we have developed in Trichy laboratory, where the breast cancer detection unit, wearable detection unit we have developed, and there now we have developed their software. Then photoimage paste patternable silver and photoconductors, thick film paste for photosensors. These are very unique photosensors. This technology also we have transferred to ceramics. Then quickly rechargeable emergency lamp. This emergency lamp is developed in Trichy laboratory. Dr. Raghu will tell details about it. Then high dielectric micro substrates technology, NTC fast response thermal sensors, and these thermal sensors are basically used in these wearable devices. Then space qualified BMP ceramics, barium titanate based ceramics. Then 6N purity cadmium, which is required in the defense. So we have developed that. Then structural grade titanium powder for the space. Then tantalum pentoxide. All these technologies already we have transferred to companies, and these are the technologies that are now ready for the transfer. These thermistor-based digital thermometers. Then graphene through chemical route, ceramic by oxygen sensor applications, graphene supercapacitor, lead-free, X-ray absorbing materials and apparents, wearable devices, then 3D analysis system for wearable devices for prediction of tumor parameters. Again, this is base, which is extension of the breast cancer detection development. Then wearable device and analysis system for early detection and screening of breast cancer. Then environmental friendly treatment of PCBs and production of black copper enriched with precision metals. So all these PCBs we can recycle in, and this plant is almost 500 kg, half a ton capacity plant is already there with us in Hyderabad, and now we can also demonstrate one of them. The aerogel based supercapacitor for electronics and application, and transparent thin heaters. So all these 10 technologies, and these are the new technologies now we have like process for nanogenic powders, then piezoelectric composition components, micro substrates and dielectric constant from 6.5 to 3. Then modified silica fillers for space application, where it is this technology we have given to ISRO. Quickly rechargeable emergency lamp. Again, this continued. When we have transfer now, we are keep rolling all these technologies, because these are not non-exclusive basis, because government is not allowed exclusive basis. Non-exclusive basis, we are transferring this technology. Then photogemal silver and quartz. Again, this ready for we can give to other companies. The nanometal based antimicrobial coating for mass fabrics during the pandemic situations. We have developed this, and we have supplied to many NGOs and hospitals. Then aluminum air battery using activated carbon derived from bamboo for low power applications. So this is the technology we developed for aluminum. We use the carbon from the bamboo. Then L5 Navic antennas. This is developed by Dr. Ratish, and this is actually the replacement for the GPS now. So we are also going to transfer this technology, and this technology is ready for the transfer. 7N tellurium and cadmium, 7N zinc for detector applications. All these high purity metals we are doing in Hyderabad. Like tellurium, we need 7N purity 99.9997 7N. And this technology is already given to space defense, because it is developed for them because they are making cadmium telluride cells, solar cells. So they are using our tellurium and cadmium. Then zinc for detector applications, 7N zinc also we have developed. And purification of scrap germanium to 7N germanium. Now we have a lot of scrap of germanium. From this scrap, we have developed this 7N germanium. So these are the technologies available, and I can tell you these are the very state-of-art characterization facilities available with us in cement as well as in Hyderabad and Trichy. On 3 laboratories, we have state-of-art facilities of characterization. We can do we have optical properties characterization and electrical characterization as well as materials characterization, all kind of like stage purity and other things like XRD, EM. So nano to bulk we can characterize. Then we have ROHS facility at Hyderabad because they can give the certification. So they have all these facilities. So Dr. Ratish will highlight that. And this is our Pune lab. We have electronic packaging where LPC is the best design and materials. I told you that we have state-of-art facility. Then nanostructure materials and composites, where nanometal alloys, semiconductor oxides, and chalcogen quantum dots in glasses, in polymers for different applications. Then additive manufacturing, 3D printing, these nanomaterials are required. So we are taking care of that. Then renewable energy, we have hydrogen generation, then solar cells, then thin film solar cells, dye-sensitive solar cells, fuel cells. And energy storage, we have all these lithium-ion, sodium-ion, solid-state flexible batteries, metal air batteries. So under the Center of Excellence for the rechargeable batteries, we cover all these areas because we are concentrating on the existing lithium-ion battery as well as future batteries, rechargeable batteries. Up to that I can say the at pilot scale, at least the problem with today is the lithium-ion battery and other batteries, the materials problem. So these materials are developed in the cement and with single cell fabrics. Then here we are further going for flexible batteries because flexible batteries will come, flexible electronics will come in the market. So we need that. Then solid state batteries. What is the solid state batteries? I will just explain in my next slide. Then sensors. Here we use gas sensor, hydrogen, oxygen, and for agriculture, NPK sensors. Then materials for strategic sectors like thermoelectric materials and radiation shading materials. All these we are working in the in cement Pune laboratory. These are the major activities where established on first time is the rechargeable battery technology center of excellence. Established LTCC based electronic packaging facility. Established country the first center of excellence on additive manufacturing, 3D printing for electronics as well as photonics. The first additive manufacturing center. Develop large scale synthesis of nanomaterials and nanostructure materials. So we have a facility. We can have 100 grams per hour or 200 grams of nanostructure materials or nanomaterials. We can produce. We establish solar cell fabrication facility. So we can make the thin film solar cells, and now we also we are also doing pyrosphere solar cells for future the high efficiency solar cells. These facilities are available in cement. Not going. Then develop hydrogen generation on pilot scale under national sunlight. This is our facility we are working on. We already demonstrated that. Then develop process for nanocrystalline optical glasses at pilot scale. Then initiated country's national center on quantum materials. So this quantum material center we are here. We have in cement Pune. Then initiated center of excellence in nanoscience and quantum dot system. This center is along with Pune universities. BST has given this center of excellence. BST has funded along with some industries. So these are the products I can say. We have a fuel cell, then we have batteries, then we can have single cell, then we have developed some lead-free aprons, then solar cells, then NOx sensors, along with these facilities.
Have you displayed some of these outside?
Yeah, some of them outside. So this is a center of excellence in batteries, where we have the all materials development. So we have cathode materials, anode materials. Then we have a future plans, sodium-ion batteries, then solid-state batteries. Now we are just we have just initiated, and we have also got some good results from the solid-state batteries. Basically, polymer electrolytes we use instead of organic electrolytes. And we started with playing with ionic liquid with polymers. So all these things are already going. We are working on that with our students. Then aluminum-ion batteries, potassium-ion batteries, flow batteries, so lithium sulfur batteries. All these batteries will have high capacity batteries so that in future. So they have some problems. So whether we can solve the problem. So we have also demonstrated how cells in vehicle two-wheeler as well as with our partner, because SPL is a partner in this project, and this cranking system batteries for 12 batteries, then flexible solar cells, and here we have flexible polymer solid electrolyte polymer flexible polymer is actually basically solid electrolyte, and then now we are going the pilot plant scale of this material, because today we have materials problem in the batteries. So whether we can make these materials available to the country, and so that manufacturing from materials to almost cell or batteries, whether it's possible. So we are concentrating on lithium-ion now, because lithium-ion now anyway when people are going to start manufacturing, so we can support them this for the materials, because materials anyway we have to import. So if this material technology is available, then the batteries cost will drastically come down. So this is the all this is we are doing in the center of excellence, and as Chatterjee mentioned that this center should be self-sustainable after 5 years. So maybe after 2-3 years, these centers will be self-sustainable. That we can have startups in this, as well as we have proposed 25 startups in this center of excellence of different with some materials, with some single cells or some solid electrolytes. So there are many things there in this center of excellence. So this is where LTCC facility in this it's a very unique facility where we can do the electronic packaging. So we can see that all equipments are devised in the clean room. You can see that multi-layers we can stack here with this LTCC based technique. So here, novel things what we are doing now today is a microcooler for packages for HPC fabricated in-house and tested at IIT. Means LTC is a best cooling system for the chip of the supercomputer. So that thing we are trying here along with CDAC. So we have demonstrated some designs now that we are just going to improve this. Then we have fabricated LC-based eddy current sensors for enable, and now there are other companies also talking for this these sensors. Then LTCC-based microfuel cells. Here we can whether this fuel cell we can stack with the LTCC-based technique like LTCC electronic packaging. So that we are trying. This program is also the IOCL is also sponsored this program. So it's very important. This is a unique thing, like fuel cells in the market. They are not based, packaging is not based on the LTCC. But here we are going to use the LTCC technique for this packaging. And this is again additive manufacturing. We have two verticals. One vertical A, we can have a 3D printed SMD components, the 3D printed antennas for communication systems, then 3D printed lithium-ion batteries like SPL is also. So whether we can have 3D printed, anyway we are doing materials. So cathode, anode, and electrolyte, whether we can have 3D printed battery. The advantage of 3D printed batteries, we can design all kind of, because you need cathode and anode, the layer structure. So this kind of layers we can design and print it properly, so that we may get good capacity in this 3D printed battery. So this is a very unique program along with two industries. I think we have two industries here, Dr. Rane and team, Dr. Shiny, they are working on that, and they will be able to tell you so many other depth of this, details of this project. So here we can already have some printers. These printers we have developed composite copper polymer and then again zinc oxide semiconductor polymer composites, and we have made the filaments, because filaments are required for this for these FFP printers. And with this, through these FFP printers, we have made this the components. So this work is going on, and basically the materials required for this 3D printer is very important. So we have 3D printers now in the market, but like metal 3D printers or ceramic 3D printers, but the materials like proper size, the raw materials, like suppose if you have aluminum components, so aluminum nanopowders or aluminum powder with aluminum ink, I can say, or copper ink, I can say, or composite like with some specific polymers. So these things are important. So all these problems will be solved in this component vertical A, and vertical B is like whether LTCC based technique, whether we can replace with this 3D printing. So we can have 3D printing, multi-layer packaging, and all this, whether we can do with this 3D printing technology. This is actually the stages of development PLP based additive manufacturing technology for LTCC based packaging. So again, this is again a new this we are working along with other industries. The industries are developing the 3D printers, and our part is materials and application areas. We are looking for the microfluidics, sensors, biomedical application, chip packaging, and there are many other applications. Yes.
There is some issue with. Will you be sharing this?
Yeah, I will share. No problem. I'll share it.
I already have contacts of all the.
So we can again one by one we can discuss. We have a half an hour. So absolutely. Now so I can go back. This one you can. You want to say this one? So this is the 3D printing. But now what are maybe LTCC we are doing about multi-layer stacking and all this thing. Whether we can do in 3D printing, because then our because LTCC takes a very long time. 3D printing can do it faster, and so that we are trying. So we have also already we are working on materials like we have silver paradigm powder, resist paste. All pastes are available. So whether we can whether we can develop some 3D printers with these components, how we can with materials and components. So this is the way we are working here, and this is again the for the stages for DLP based additive manufacturing technology for LPG based packages. As I told you, all these applications we are looking for is 3D printer. So this is actually light based. I can say the UV curable resins will be used for in the stacking the multi-layers of this some of the circuits, and we can this DLP printer can be. I think we have got one DLP printer, so we are our one industry partner is also there. He is also working together. He is also developing some these DLP printers as well as some, because for specific applications we need a little design change in the 3D printer. So these industries will help us, because CIMET cannot do alone all these things. So our part is the material part, whether we can have the material part, and then we know the processing of the components and processing of all these things, our ceramics. So whether we can explore this with these DLP printers. These are the nanostructures, all kind of nanostructures we make. We have one-dimensional nanometers, two-dimensional, three-dimensional, then hierarchical structure. As I told you, we can make more large-scale production of nanomaterials. And we have quantum dot glaze glasses where we can develop quantum dots in glasses, in polymers. So for different optical applications, we can use that kind of filters. And same thing we use for as a catalyst for the first time for hydrogen generation. We produce 2 liters per hour hydrogen generation under natural sunlight, hydrogen sulfide, water, and this is our solar cell facility where we can have a thermal evaporator there. We can film coating, and I think that can. So this again the National Center for Quantum Materials Technology. This is basically supporting the quantum computing technology, and where the target variables like we have diamond subsets for quantum technology, 2D dielectric between boron nitride, superconducting nanowire substrate for single photon detection, quantum materials and sensing for like 2D materials, quantum dots in liquid suspension. All this we have to. These are the targets for us. And expected outcome is the diamond-based qubit and quantum sensing, whether we can see that. Then wafer scale 2D materials and SNPCO detector technology for qubit. So all these things are required in future. So we have started in the CIMET, and we'd like to involve the industries from the day itself, so that we can some of the technology we can take it at some scale, and whether the industry can come forward to for commercialization. All these things are that's why the today's industry interaction with CIMET. So I'm just very hopeful that all these industries can come forward and join such kind of center of excellences as well as mission program, so that these developments will be little faster. So this is the very uniqueness of this activity, because this is the first time the center we are created in the CIMET, and thanks to our Sandeep ji and other people, because they have supported a lot such kind of very important area. So neutron energy materials for development of Wi-Fi. You know that neutrinos are available around us, and they are it's there. It's a little mass is there for the neutron, and it is well known that this neutrino has some energy, whether this energy can be captured. And this some of our collaborator here is German neutron energy German. They have already come up with some small devices of this. So whether we can develop the materials, because material development is a part there, like I said, is again a 2D material with quantum dots. It's very and the high quality graphene with semiconductor quantum dots decorated on this graphene will be helpful for capturing the energy. I cannot say capturing this. Some of the energies will be converted into the different, like in batteries, like chemical energy is converted to electrical energy. The same thing will also possible in science. The target is how whether we can make a car, so that this car can be charged when you park the car in our parking. So automatically we get charged in the morning. So this kind of things already we have already started working on these materials, and our part is materials, and there is a design of car and how to make this prototype car and all this. So this very again a very important area which we in collaboration with Sharma group we are doing. So this is our vision. So all these materials and all this, we can take it to some level where up to pilot scale, and then transfer to industry. Some of the materials in 2032, some of them in 2037. So we have already made a plan of 2047, and all these technologies stages we have already mentioned here. So and here to make this successful, we need the help of the industries so that we can make this Atmanirbhar Bharat. No? So our Modi ji is telling that we should have our own technologies and all this. So how to make use of this and how to involve industry more in the along with R&D. So that is our mission here. Thank you very much. This is our because I have completed within 20 minutes because we have to hear from my other directors. So thank you very much. I think we'll go to next presentation.
Sir, as you were speaking, I just got an update about one of your colleagues. Dr. Milind Kulkarni has won the 2021 IESA Researcher of the Year, PSU, for energy storage. And, the award will be given on 3rd of May.
Yes.
Artist congratulations.
Yeah, at Pragati Maidan, Delhi.
Correct.
So I will take this opportunity to acknowledge support from our ministry, from our group coordinator, Kumar sir, Director Dr. Sandeep Chatterjee sir, for funding heavily to our all ongoing and sponsored project. As well as I would like to give the credit of this award to our Director General for his encouragement, all my colleagues at CIMA, our Registrar Madam, our admin section, finance section, who has helped me to complete the project activities in time. Last and not least, the support from my research scientists, our RA, our students who are behind the curtain, but they have definitely helped for me to complete the project activities in energy storage. Thank you, one and all.
Thanks. So I would like to introduce our next speaker, Dr. N. Raghu from Director CIMET from Thrissur. So Dr. Raghu has done his PhD from Indian Institute of Science, Bangalore. His area of research includes actuators, multi-layer ceramics, electronic packaging materials. And he has successfully completed more than 15 research projects. There are, of course, many patents and publications to his name, and he has also been honored with many awards for his work in the above domains. So I would like to invite Dr. Raghu to give his talk on sensors and actuators, graphene mission program, and technologies which are ready for transfer with CIMET. Over to you, sir.
Good evening. Am I audible?
Yes, you are.
Thank you so much. Good evening, and I'm really honored and privileged to speak in such a forum. Thanks to MCC. Sorry, I forgot the full this one.
It is MCCIA, sir.
IA.
Will you be showing your
Pune.
PPT as well?
Yeah, MCCIA Pune for giving me such a wonderful opportunity for us. Can I share my?
Yeah, you have the sharing rights. You can share your PPT.
Sir, my slides are visible.
Yeah, we can see the slides. Please continue.
Thank you. I'll make it fast. First of all, my apologies to Dr. Ratish. I need to rush through. That's why I took over earlier than his slot. Sorry. Coming back, I'll make a very quick presentation of what we have done as far as technologies are concerned in these 4 major thrust areas in which we are working. First thing that I would like to tell you is that the thermal sensors is the one that we started way back, and this we have gone from right from the raw material, which is absolutely indigenous. We have made varieties of materials that are needed for varieties of applications, because these things have applications for in anything that you look for. Like, for example, the home appliances, right from your AC to fridge to whatever. In automobiles, in medical, you name any field, these things are very, very essential. So all these materials and the related electronic components, we not only made the material, we made the chip thermistors, we made the chip in glass thermistors, we made the thermistor probe, and we have transferred this technology 2015 back to the beam sensing technologies at Bangalore for automobile application. Having developed such sensors, we moved on and came out with an out-of-the-box thinking in association with a cancer research institution, and thought of why can't we use these sensors to at least mass screen a village or a block entire or the entire society if given a chance, because this is such a simple thing. Every day, whatever innerwear the ladies are wearing, in the same thing, our sensors have been put inside, and within 15 minutes, no pain, nothing, very simple, easy, user-friendly, no compromise on the privacy of the ladies. These are the positive point of all these technologies. And these technologies have been transferred. This has been developed, and this has been benchmarked with the gold standards such as mammography or whatever you would call. And these technologies have been developed in association with the Malabar Cancer Center as well as with the CDAC at Trivandrum. And finally, the doctor need not have to know anything about what is happening. He will get this kind of pictures on his screen. So by looking at the picture, he will know whether this is a potential case for breast cancer or not, for which the scientists got the President's Award as well as appreciated by the PM. Moving on, we also developed the, having developed such two-dimensional way of looking at the breast cancer, can we have a three-dimensional analysis so that we can pinpointedly say in which quadrant of the breast you have the lesion and what are all the metabolic heat rate and other parameters that are needed, so that they get a much of this. This entire thing you can finish off in 15 minutes. That's the whole story. And this is how we can do the entire analysis. At each slide, the breast is considered as a sphere, and all those modelings have been done. We can pinpointedly say at what point the lesion is available. So this particular technology has also been transferred to the same. This is a multinational company to whom we have transferred. Extending the same, having developed such thermal sensors which are fast responsive, we came out with products like clinical digital thermometers, industrial thermometers, as well as for laboratory purpose. And variety of thermometers have been made, and we have the what do you call this? Trade this one. That means the designs patent for all these things, so that we'll be able to transfer this technology. These things have been made by us, like even the design is patented, so that the 3D printing of the design and including the components, you put everything, so that this is totally indigenous technology. Having developed this much on the thermal sensor based work, we have now moved on thanks to our ministry. We have a center of excellence, as Dr. Sandeep as well as Dr. Kale was explaining. It's on IoT based sensors. So this will have a 360-degree angle, look at every possible things. Not only it will look at research and innovation, it will look at a common facility center where startups and SMEs will be absolutely supported. It will have an incubation center to ensure that whatever technologies that come out of that are completely supported for at least 2 to 3 years before they take off. A capacity building will be considered, where training on machinery, tool design, all those things will be taken into account. Quality assurance will be ensured, and integration onto device will also take place. This major program is being supported by our own ministry, and Government of Kerala has given the land and the building, and industries have also chipped in. You are also most welcome to see if you are interested in any of these areas. You are most welcome to contact us. Within this initial period of less than 6 months, our people have already made IoT-based sensor devices. If you can see onto your right-hand top corner, that is the IoT-based fire alarm. And the one just below that is the IoT-based smart thermometer. So already we can feel that all these we are converting into product mode so that the technology is available and it can be taken up by the industries. And in the coming years, these are all the IoT-based sensor products that we have in mind. If any of you are interested in development of any of these IoT-based sensor, you are most welcome. Or if you have your own IoT-based sensor requirement, wherein it merges with our trust area, then we will definitely be happy to help you out or see how best we can collaborate together. Having talked about the sensor part, now I'm moving on to the actuator part. I will come back. I think it is slightly difficult. If at all there is any difficulty in understanding what is actuator and all, kindly don't worry about that. What I'm trying to tell you is that this is a material that is, I'll first give you very common, simple examples of this piezo material, then you will get a clear clarity. Whatever the sound that you get in a telephone ringing, whatever the sound that you get from a buzzer, whatever the sound that you get in the automobile, all the, even your automobile, you try to park and take a reverse, there is a sound that comes out, right? All those things are made out of the same material, piezoceramic materials. And even your gas lighter, when you press it, you can see that one spark emerges, right? Those are all piezoceramic materials only. So we have our own unique material, which is totally indigenized and which has been tested and validated for various defense applications, because the same material, we can put it for underwater acoustic communication so that people will be able to identify, is there a submarine? So such kind of defense applications are feasible. This has been tested at National Physical and Oceanographic Laboratory at Cochin. This technology is available. And we made a variety of actuators. Actuators are nothing but that helps you to attain precise movement in micron range with nanometer precision. We have made various designs of these actuators entirely for strategic applications like defense, space, and these things also have lots of common public applications are also feasible for this kind of sensors and actuators. So anybody is interested in these kind of piezo-based sensors and actuators, we will be happy to shake hands. These are all flexible piezoceramic polymers, and apart from that, it is also transparent. So we have demonstrated these piezo-based polymer, flexible polymers, both as a speaker as well as a microphone. This has been validated by a third party so that we get the complete clarity about our development. Now, moving on, what we are currently doing in this piezo-based activity is that all the ultrasonic ultrasound machines that we have, the heart of it, the ultrasound really emanates from a piezoelectric probe. So our own ministry funded a program to our own sister laboratory, another institution called NILET at Calicut in Kerala. They developed the indigenous ultrasound machine itself, but the heart was missing. That was imported. So now we have taken up that so that it will become a completely made in India product, absolutely indigenous, to satisfy the government's requirement of Atmanirbhar Bharat. I am now moving on to the next major area, which is called Plasmonics. We don't have to need to know what it is. There is no need to know what it is. All I'm trying to tell you is that we have coated a material on this glass. Nobody knows that there is a material there. But if you connect an LED, it just glows. So the reason is that this material is transparent. Nobody will know. And this is also conducting. So I can use it for strategic purpose, where sensitive information or you need to monitor without anybody else knowing what is happening. You can use for such kind of purposes. Second, in an automobile, you can see that backside that heater lines are going. What happens is that when you apply the current, it helps you to remove all the so it gives you, but still you lose the visibility. But yes, imagine that I have these kind of conducting lines going, which is also transparent. Absolutely, my visibility is ensured. So such beautiful applications are feasible. Even in a freezer in a supermarket, you can see this kind of haziness. So you just apply a small voltage at frequent intervals to ensure that these haziness goes away. These kind of we can look for common applications that are India specific. So extending this work, we have made simple disposable sensors for two major purposes. One for as a biosensor. So if you want to know whether the food that you are eating is really worth eating it or not, within a fraction of a second, we'll be able to say whether it contains E. coli or any other bacteria. Otherwise, we have also exploited this technology on a fiber optics to ensure that we can detect gases like ammonia, hydrogen, etc. So these kind of technologies are also available with us. This is in a nutshell that we have made disposable and cheaper, cost-effective sensors for both bio as well as for this one. You can see the limit of detection is around 10 ppm for ammonia, and you can play with the frequency. Like if I want to happen at a visible, I can play with that. If I want to happen at the NIR, so where the current technologies are available easily, state-of-the-art technologies are available for its detection. So we have planned all these things, and thanks to our scientists, they have come out with the complete sensor module, number one. Number two, they have also made disposable sensors, so and which is absolutely cheap. We are extending this technology now again with Malabar Cancer Center for cervical cancer detection and all other cancer biomarkers. And people are coming to us for understanding whether snake venom can be detected, whether one can even understand, this has come from Gujarat Milk Society, whether we can understand the quality of the milk. Our answer is yes, and we are working on those things. Next area, major area for us is the energy storage. Batteries, as Dr. Kale was mentioning, is a key technology of the Pune Center. Along with batteries, you also need supercapacitors if you are thinking in terms of electric vehicle or for any other power electronics application. We have a pilot plant facility, once again, thanks to our ministry. This is the first pilot plant facility in India that produces more than 4 kgs of one of the lightest known material in the history of humans, known as aerogel, because it contains more than 90 to 95, more than 95% inside that is basically air. So such lightweight materials which are needed for such applications we have made, And we can also come out with these kind of technologies with, if you want a very light material but is absolutely insulating, we can also think about it. If you want it to be conducting, we can also think about it. We can play with these kind of materials. And we are currently working on supercapacitors for essentially for EV application. And we are also now moving on with aerogel-based supercapacitors along with our ECIL for electronic voting machine purpose. We all know that whenever we go to the cooling booth, along with the electronic voting machine, you also have what do you call that, VVPAT. That means voter verifiable paper audit trail is there, right? So this contains somewhere around normally 30 WA batteries, which are just used only for that particular occasion, and it's thrown out. It's environmentally creating problem. Second thing is that it is the energy of that is hardly used. So at least we can, if we have a combination of battery and these kind of supercapacitor, we can save a lot of energy, power, and it is you can use it repeatedly. I think this is what we are trying our level best with ECAL at Hyderabad. You might have heard about the wonder material, which got Nobel Prize for the inventor somewhere around 2016 or so, known as graphene. We are making this graphene powder at our center. And if anybody is interested in using graphene for various applications, synthesis of graphene itself is available as a technology from us. And we have also demonstrated its application as graphene-based supercapacitors. This is a slightly older slide. I'm extremely sorry. I put it as 100 farad. Actually, you can see in the picture, we have gone up to 300 farad. All these white ones are our own CMET product. On the other side, what I show are the equivalent commercially available supercapacitors. CMET Thrissur, this was done for ARDE at Pune, which is a defense laboratory, and they want electronic time fuse application for firing of electro explosive devices. So graphene-based coin cell were made. Not only that, we made the banks so that you get the required voltage and other parameters. And they have not only given us a certificate, they have made it clear that this was one of the best R&D, and for this also she got the award. These are some of the applications that and demonstrations of various things. For example, like how the operation of a 15-watt DC fan or in an UPS, and all those demonstrations have been done to prove that variety of applications are feasible with our own supercapacitors developed indigenously. These are all the products, as I told you, has been made, design has already been, we got the trademark from the patent office. And these are all the features that we have. Dr. Kale was mentioning about the quickly rechargeable solar cells, the emergency lamp, which I have not projected here. That is, you just have to power it for 1 minute and it gives you power for 1 hour. So in remote locations where frequent power is a problem, one can think of utilizing that. That has also been transferred, and these kind of products are also available for technology transfer. And this is another area where we are doing with an industry. I think sir is also going to speak this thing, if I'm right. This is an industry that's available, Spel, SPEL is available at Pune only, in association with them again for e-mobility program. The capacitor that they are using is polymer based, which cannot withstand the temperatures. So we are thinking of coming out with equivalent capacitors, but which can have much, much higher temperature handling capabilities. This is one industry related project that we are doing. This is a major international program, and I am happy to say that our scientists are able to grab this opportunity. This is totally funded by UN, where not less than 21 countries are involved. And out of 117 institutions that tried to get into this program, 17 have been selected, and CMOT Trishur is one among that. And thanks to all the young scientists who are doing this excellent job. This is one technology, and now I'm moving on to another area called microwave materials. And thanks to Dr. Ratish, who is currently the CMIT Hyderabad director. These are all the technologies that was developed and initiated by him when he was here. This is a particular material we all use our mobile. Mobile stations are there, and satellite communication, they need to have, how does the microwave energy emanates, how does the microwave reaches the other side and gets received. All these things are because of these kind of materials. These materials have been indigenously developed, and it has got potential applications as in satellite communication as well as for mobile base stations, etc. This is another major area where Dr. Ratish has put all his efforts. And you can see why I'm projecting this particular, this one is that this was the monopoly product of one US company way back 25 years back, if I can, 25 to 30 years back story I'm telling. Even now they are the monopoly, no doubt. Such product some 10 or 15 years back, ISRO came and told us there's absolutely an embargo item for us. Can you help us to make it? So Ratish put all his mind effort for that. Now you can see how we are transformed. All these are indigenized. Wherever I have put CMET, the same equal products with different dielectric constants, we have also made our own products, indigenous, absolutely. And for all these things, we also not only got Indian patent, we also got the US patent. And we have, thanks to the atomic energy, it has fully supported us in this. We have this flexible, that means if you want to make any microwave-based device, be it a filter, be it an antenna, be it an oscillator, whatever you want to make on anything related to microwave, basic requirement is that base. That base, it's like your PCB, but this has to be a flexible one. So we have the complete pilot plant, and this is fully supported by atomic energy. We are supplying it to them. Plus, we also have lots of industrial partners with whom we are associated. This technology has been transferred to a company in Bangalore, in Hyderabad, and they are going to come out with indigenous product, 100% made in India, probably in 2022 itself. And if you can kindly see, this particular area was missing, the left-hand side. We have started working on those ceramic hydrocarbons also, and we have made all those equal products. What you see, that 4 or 5 products, we have made this, and now we have the complete range that a monopoly US company can offer. We can proudly say, thanks to all these youngsters, that we can proudly say that we have made all the indigenous. And this has been tested and validated by Defense, Department of Atomic Energy as well. Moving on to another major mission program, as Dr. Kaleji mentioned. This is on India Innovation Center on Graphene. So we are now trying, this is one of the major program again, supported by our own ministry, thanks to them. Government of India, Government of Kerala, which has given a lot of money in terms of the land and building. And we can see it's almost 86 crores proposal. Tata Steel itself has chipped in with a 7 crore budget. With all others, it's around 11 crore. So it's such a major program. We are thinking this will be more, not even a simple project of CMET. This will be almost like a national program we are envisioning. And these are all the varieties of products that we aim that will come out in the next coming 5 years. This program has just been sanctioned and the building has already been allotted to us. Now we have to establish the facilities and we have to come out with each year. We have already identified what are all the products that will come out of these through this particular thing, covering a variety of field, including electronics, flexible, displays, and optoelectronics, a variety of other fields also, sensors, actuations, all this we are trying to cover. I just want to also show that we make nanomaterials, but we don't confine it making into a few grams. Wherever it is essential, we have our own pilot plant so that we produce it in cages so that it is demonstrated at a pilot level so that it becomes easier for the technology to be absorbed by an industry. These are all the technologies that have been developed in the year 2021. As I mentioned, digital thermometer, graphene itself as a material, graphene supercapacitor. And if anybody needs a flexible ceramic tapes, of course, we have put it for oxygen sensing application, but it can be for any other application that if anybody is interested in terms of flexible ceramic tapes, we are on the job. I think this is almost like repetition of whatever I've already told, so I'm skipping this slide. We have 100% clarity, regardless of who is available today, who is going to leave tomorrow. We have our vision for 2047. All these are feasible only because of the excellent support that has been extended by our ministry and the government of India. Thanks to the ministry, our headquarters, and thanks to your patience. As I mentioned, all these gimmicks, or it is not gimmicks, I'm extremely sorry for using the wrong word. All these excellent product development has been done by a handful of scientists. I'm mentioning today 13 scientists, but till just a year back, we had less than 10 scientists. So these people, in spite of having excellent opportunity to have an excellent life of settling themselves at the US, UK, Europe, and various other places, and some of them had a PR opportunity also. They left everything and came back to India and served. Kudos to all of them for all the excellent work that they do. Thank you so much, and we will be happy to cooperate and collaborate with you and see how best we can serve the industry's requirements. Thank you so much.
Thank you. Thank you, Dr. Raghu.
I'll try my best to come out of this. I'm not technology savvy. It will take me a minute. Kindly give me a permission.
Will you be sharing the slides with us?
I will try my level best, sir, because I think most of them are general. I will try my level best to share it to Dr. Kale, sir. Okay.
Sure.
Yeah,
because there are some people who have registered but not attending today. So probably, and plus those who are here also, they will benefit from it.
I understand, sir. I will try to condense this and put it across to Dr. Kale.
Sure. Thanks.
Thank you.
Thanks.
Yeah.
So we move on to our next speaker for today, Dr. Ratish, who's the director of CMET Hyderabad. Brief introduction. Dr. Ratish has a PhD from University of Kerala. His main area of research includes microwave ceramics, microwave laminates, polymer ceramic composites, ultra low temperature ceramics, antennas for NAVIC and GPS, and e-waste management. So he has successfully completed more than 15 research projects, and he holds many patents and has published papers in many national and international publications. So I would like to invite Dr. Ratish to give his talk on high purity materials and technologies available for transfer with CMET. Over to you, sir.
Yeah, good evening. At the outset, I thank MCCIA for giving me this opportunity to make a presentation on the technologies which is ready for transfer at CMET Hyderabad. Unlike what Dr. Rekku was now presented, CMET Hyderabad laboratory is mostly working on semiconductor materials and strategic metals for variety of applications. I'm just showcasing the kind of work which is being done at CMET Hyderabad. And you can see that with respect to each work we do, we have an end user attached to this. Let me start with silicon carbide. Like, you know that the country missed the bus. Because of that, we don't have any silicon foundry. Whereas we started silicon carbide, which is a much better, substrate material, back-end substrate material for semiconductor devices. This work has been initiated with the DRDO. We have the first silicon carbide, growth facility, PVT reactor growth facility at CMET Hyderabad. I would put it in this way, like CMET Hyderabad laboratory work like Fraunhofer institutes. We produce strategic materials for the country. We house country's first hafnium production facility. I'll talk about it a little later. This is a very strategic material which is used as a control rods in nuclear submarines. It's also used as an aerospace alloy. The thrust area of this particular laboratory is on high purity materials. Currently, this is an endangered species of research. Only a handful of institute other than CMET, only BIAS is working on this to the best of our knowledge. We produce 7N purity materials for strategic applications. I'm just trying to emphasize the word produce, not only develop, we cater to the requirement of the country. And another societally important work which we do is on e-waste recycling technologies. As Dr. Sandeep Chatterjee has pointed out, we house country's first center of excellence on e-waste management. Apart from that, we have work on Navic antennas and MEMS sensors. Last but not least, we are the first and the only one government-owned facility for restriction of hazardous substance compliance. So let me start with silicon carbide single crystal growth. This particular work has been initiated for strategic application, but we have started at the right time. Maybe more than 80% of the silicon carbide applications are for commercial sector as of now. For example, EV, electric vehicles, you need fast charging and discharging switches, which can be manufactured only with silicon carbide technology. So we do have both 4H and 6H silicon carbide single crystals, which is developed through a process called physical vapor transport reaction. So this is the physical transport reactor, which is from Axtron, Germany. This is the first reactor which is imported to the country for silicon carbide single crystal growth. As you can see, we have already grown silicon carbide single crystal, both 4H as well as 6H, using this particular reactor. And together with DRDO, we have further machined, polished, and sliced these wafers for device applications. So gallium nitride technology together with silicon carbide, you can come out with various devices like high energy mobility transistors, HEMT devices. So here you can see a feel for it, how the silicon carbide single crystals developed at our laboratory. Whatever is shown on the first is an imported 6H silicon carbide seed crystal, and whereas whatever is given on the bottom is a 6H silicon carbide single crystal, which is indigenously grown. One of the very important properties to qualify them for device application is the micropipe density. As you can see that the micropipe density of the wafers made at CMET was less than 20 centimeter raised to -2. That means the targeted micropipe density was less than -100, which is much better than the imported silicon carbide wafers. So we have already made, many devices out of that. Of course, this work has been done at DRDO. The entire, development work has been done in collaboration with SSPL, New Delhi, as well as DMRL, Hyderabad. But the advantage of this technology is, though we have developed it for, DRDO, most of the application lies with the commercial sector. For example, 5G communication radars, EV vehicles, and solar cell modules, inverters. So all these devices require, silicon carbide based switches. So another very important milestone which we have achieved is on semi-insulating silicon carbide. Only handful of countries have semi-insulating silicon carbide because it is used for high-end semiconductor application. For example, electronic warfare, SATCOM, point-to-point radio, phase shifters. The problem is, whatever I've displayed or demonstrated in the previous PPTs, these were conducting materials. Whereas you need a semi-insulating material for making, high energy mobility transistors, which is used in Mach 4 and Mach 5 missiles, which is also used in some other critical applications for defense and atomic energy. So this technology is not given to India. That is one issue. When we have asked for this particular technology from a manufacturer, the amount quoted for this technology was 10 crores with a condition that their government should permit them to transfer this technology. I'm very happy to share with you that with focused and coherent efforts, CMET could develop semi-insulating silicon carbide technology, which can be now rolled out for most of these critical strategic applications. As you know that our ministry is now coming out with the 78,000 crore semiconductor program. I'm sure that this particular development is going to support semiconductor, sustainability in the country, material sustainability in the country. So as you can see, though we have achieved all other properties in the earlier phase of this development, we could achieve more than 10 raised to 6 ohm centimeter, which is one of the very, very critical properties for, electric vehicle applications. Wherever you have high power handling capabilities, you need to have very high electrical resistivity, and we have achieved that. And now the next goal is to go ahead with the, silicon carbide wafers and devices, development using fab facility. Especially you need gallium nitride fab facility for this. We are working towards accomplishing this goal. This is about, silicon carbide back-end wafers, which we have already developed and which is ready for transfer. The next project which we are doing is a societally important project, which is on e-waste management. You know that more than 90% of the electronic waste in the country is now being processed by informal sectors. If you look at places like Moradabad, most of this electronic waste is handled by informal sector. When you process it in informal sector, the problem is that a lot of, like flue gases, like furans, all these toxic gases which comes out, which contaminate the environment. And this more than 4 lakh people are working in this area, and they use their bare hands to handle, this poisonous chemical like potassium cyanide to process these kind of materials. This is one problem. Next problem is that most of the electronic waste contains a lot of valuable metals, but the yield of process is, or yield of production is only 25 to 30% when you do it in an informal way. So looking at all these, we have set up country's first center of excellence on e-waste management, which takes care of industry ecosystem, innovation ecosystem, and capacity building. I'm extremely happy to share with you that one of the renewable industries have invested 7.16 crores in this particular center of excellence for collaboration, industrial collaboration. Very recently, we have signed an MOU with this particular industry. This is not a CSR fund. They are putting hard currency to this project. As you can see, this 40% of the money comes from IT, our own ministry, 40% from government of Telangana, and 20% of the money is coming from an industry. And we do support startup ecosystem, incubation ecosystem, technical hand-holding, consultancy services, and technical services. Because of the positive time, I'll just go little fast. So we nurture this kind of technologies. One is PCB recycling. Then the next technology which we nurture is on lithium-ion battery recycling technology. As you know that both cobalt, nickel, as well as lithium comes under critical materials. Already European Union has already identified 27 materials which is under critical materials. So these are 3 materials which fall under that. So we need to definitely recycle this material for, under resource efficiency and circular economy. The third technology which we nurture is on recovery of rare earth oxide, especially neodymium oxide from spent permanent magnets. And last but not least is about solar cell recycling. I'll touch upon that. I'll just talk about PCB recycling technology little detail, because you know that when you process 1 ton of ore from Kola mine, you will get only 1 gram of gold. Whereas if you can process high value or medium value printed circuit boards, 1 ton of PCBs will give you 250 grams of gold, apart from silver and copper. So this is called urban mining. Unfortunately, currently, most of this PCB is being processed at the informal sector, not at a formal recycling agencies. Otherwise, it is being exported to countries like Belgium or Japan for recycling process. So it is imperative that the country should have a robust and environmentally benign process for the recycling of printed circuit board. So we have already developed a process. We have already gone for a patent also. This technology composed of depopulation, then shredding, followed by smelting, casting, and electrolysis. So you can see that one of the very important aspect of PC or like e-waste recycling is not only the process. The equipment which are used for processing is also paramount important. So what you see on the left side is a toe-blown rotary furnace which we have imported from Italy for a cost of 1.30 crores. But most of our e-waste recyclers are unable to bear such kind of a high cost. So we have also started designing equipment which can be rolled out throughout the country for e-waste recycling. So what you see on the right side is front firing furnace, which is 1/4 cost of this FF50RF, wherein we should be able to do this kind of PCB recycling. This is a smelting process wherein we are recovering the valuable metals as a black copper. What you see on the left side in a yellow background is a black copper. That will be further processed through electrolysis to recover 99.9% copper, 99.9% gold, silver, as well as palladium. This technology is ready. But what is very important as far as e-waste recycling technology is that environmental friendliness. As you can see that this testing has been done on the flue gases by a CPCB approved agency, and the limit of furan and dioxins are only 1/3 than the allowed limit. So this technology is in a technology readiness level of somewhere around 6 as of now. We are able to process 300 kilogram per day spent PCBs per day. We do have an incubation facility. Anybody can walk in with 100 kilogram of PCBs and we will do it for the cost. very small cost, and we'll give them precious metals back. This is to promote e-waste recycling in the country. So currently we are going with 1,000 kg per day facility, like so that why? Because if you want a return of investment within less than 2 years, you need to do a processing of materials at a bigger scale. So we are in the under Center of Excellence, we are in the process of developing such kind of things. So the other technology which I want to showcase is lithium-ion battery technology. Almost 18 industries are now given expression of interest for absorbing this particular technology, wherein we are going to recover all valuable metals, cobalt, lithium, nickel, and manganese in their respective salt, so that we can utilize this material as an input material for further battery manufacturing. The purity of this particular material which we have recovered is of the purity almost 99+%. This technology is scalable, which is suitable for big players, but as one of the objective of our Center of Excellence is to also promote small players, SMEs. So we have developed a pyrometallurgical route also for recovery of valuable metals from lithium-ion battery. This is through a smelting route, wherein with less investment we should be able to recover valuable metals from this. So this is the lithium-ion recycling process, where it promotes resource efficiency as well as circular economy. We have already set up a pilot plant inside our campus for hand-holding of industries. So the third technology which we nurture under Center of Excellence is the Spel, permanent magnet recycling. You know that if you want to recover neodymium oxide, which is one of the major ingredients for NdFeB magnet for permanent magnets, you have to go process ore. If you require 100 kilograms of neodymium oxide, you have to process 10,000 kilograms of monazite. So you see the kind of environmental impact which creates, and we don't have sufficient quantity of basic ore also in the country. So we decided to recycle the permanent magnet. There is a very big program which is going in Europe, which is called Sustainable Magnetic Program. Europe is not going to depend on China or other countries for rare earth oxide. They are going to recover all rare earth oxide only from secondary raw materials. So the kind of purity which we achieved is at par with the alpha acer grade. More than 99% pure neodymium oxide is extracted from this recovered permanent magnets. This technology is also ready for dissemination to industries. So we also started a human resource development is also one of the major objectives of the Center of Excellence. So we started a MTech program with IIT Hyderabad. This is also one of the unique feature of our Center of Excellence. So this is very interesting. Like one day one young boy walked in and he told that I'm graduated from Indian Institute of Science, graduation and post-graduation from Indian Institute of Science. I want to join as a startup. And he is now working on a very interesting project wherein he is trying to recover indium and liquid crystal from displays, mobile phone or LED displays. So we nurture startups on this line. So the other, apart from permanent magnets, we are also working on silicon solar cell recycling. So these are the recovered materials from this silicon solar cells. Mostly it contains glasses. This antimony containing glasses almost 80%, but it also contains silicon cell fractions of around 5%. We do have copper and silver in small quantity and EVA as a backend this on material. So we recycled the entire value chain from silicon solar cells. So these are some of the purity of. Then another very important aspect as far as CMET Hyderabad laboratory is concerned, these recovered materials can be purified further because we have the technology for purifying every material up to 7 mpurity. So if at all the purity of the recovered materials are not adequate, we should be able to further purify it through vacuum distillation or induction zone refining, so that we can also do value addition of all these products. So now I'm coming to high purity materials. So the objective of this this laboratory itself is to develop semiconductor materials up to 7N purity and cater to the strategic requirements. So we started, this is a spin-off of special materials group of NFC, wherein they were initially doing high purity materials development. So we process germanium 3 and germanium into 7N purity germanium. You know that germanium is a very critical material, especially for radiation sensor applications. So this end of life germanium scrap material, which has come from DRDO or SSPL, is purified through induction zone refining. This is a new method which is being implemented at our laboratory, and we have also filed 2 patents on that. And we are able to purify germanium up to 7N purity in 1 kilogram per batch level. As far as high purity materials are concerned, 1 kg batch level is of very high quantity because you require only very small quantity of this material for sensor development and all that. So this is the high purity materials analysis which is being done for NRC Canada. This is the litmus test which we need to do because third party analysis is a must for qualifying any high purity materials for further usage. So apart from that, we cater to the requirement of high night vision cameras in the country. Mostly night vision cameras are manufactured by CIA, and we produce the cadmium and tellurium, 7N purity cadmium and tellurium required for night vision camera production. This will be given to SSPL. SSPL will work together with CEL to produce night vision cameras. So we have a number of projects which is being executed with DRDO to cater to the requirement. We do have patents on this. We have almost 2 patents on even equipment manufacturing as well as purification of these materials. This is a totally indigenous technology right from the development of equipment to purification of metals. These are some of the vacuum distillation and zone refining systems which is being developed, which is being designed and developed at our laboratory. We do have class 10,000 clean rooms for high purity materials. So not only cadmium, tellurium and germanium, we also work on requirement driven purification, like zinc is required for a radiation detector application. But here the problem is that they don't require it in ingots. It has to be in the form of granules. So all customary work, so based on the user requirement, we undertake such kind of work because making zinc granules with 7N purity and 3M diameter is a Herculean task. But we could do that, and this technology is also available with us. Why I am showcasing this? Because we can also follow any kind of purification work with respect to the customer requirement. These are some of the vacuum distillation system and metal granulation system which is indigenously developed as well as patented by us. So coming back to that, Dr. Raghu has showcased many sensors which is being done at CIMET Thrissur laboratory. We are working into MEMS-based sensors. This is a bionic sensor. One of our scientists who has worked in Indian Institute of Science, SENS, for many years, is an expert in MEMS-based devices. So this particular work is being done for Naval Oceanographic Laboratory of DRDO at Kochi. We are trying to mimic a fish-based sensor. So how it moves, this is especially for sensing submarines inside sea. So we have already developed, we use silicon etch, thermal etch, followed by PECVD oxide etch, and then we will come out with bulk silicon etch to this kind of devices. So in a single silicon wafer, we should be able to come out with hundreds of such devices which can be tested underwater. This is just to showcase all those. So let me also tell you, we produce the entire hafnium required for the country. Okay, this is a very important research project which is being implemented only at CIMET Hyderabad. You see that like how we do Fraunhofer kind of research, starting from technology readiness level of 2 and taking it up to 4 and now up to 7. So what you see here is, so basically for all satellite nozzles, you require, neobat alloy. So the neobeam is produced by NFC. Is my time over?
Sir, another 5 minutes max.
No, I'll finish it off within 5 minutes. Okay. So we produce the entire hafnium required for the country, like it is used for satellite nozzles and all. This is the metallurgical process through which we produce hafnium. We take work order from ISRO and we produce this. This is the pilot plant where we require 80 people who has to work 24/7 to produce this particular material. And we also get ICC award for best plant design. Currently, what we are doing is that we are making hafnium metal sponge using purification of metal sponge for electronic application. Electronic application means we wanted to use it as a gate oxide material. Currently, SiO2, silicon oxide is used as a gate oxide material. Now we are using hafnium oxide as a gate oxide. So this can be used as a thermal insulation coating for a re-entry launch vehicle also. So together with that, we also, like, once we have developed a number of processes for hafnium, one process is called chlorination. We are now doing carbide-derived carbon for supercapacitors. This is another work which we do together with ISRO. So another work which we are doing is, as you all know, that the country is going to switch over from GPS to NAVIC, that is navigation with Indian constellation, very soon. We have launched 9 satellites. CMET Hyderabad is making, antennas for navigation with Indian constellation. You can see that we work on, like Dr. Reddy was mentioned about PCBs, high-end printed circuit boards. We use that high-end printed circuit boards for making, dual band as well as tri-band antennas for navigation with Indian constellation. These are some of the gain measurements and other details of these antennas which is being developed in-house. So we also develop absorbers, microwave absorbers for Indian strategic sectors. This is a sandest alloy which is used in the linear accelerators. So now the last slide which I want to project is on restriction of hazardous substances. Industries can avail this facility. This is a self-sustainable facility. Any EEE product which you want to qualify, you can send it to us for compliance. So this is a self-sustainable ecosystem. You can see that these are some of the product which is being tested and compliant by us. The door heating elements, digital thermometers, AC adapters, and all that. These are the technologies which are readily available with us transfer, which is EBS recycling, PCB recycling technology, hafnium metal sponge production, lithium-ion recycling technology, recovery of rare earth oxide from permanent magnets, then tantalum powder. This technology for tantalum powder, 7N purity cadmium, 7N purity tellurium, gallium, neobate thermite, and 6H silicon carbide single crystals. Thank you so much for your kind patience.
Thank you, Dr. Ratish. Sorry, we had to rush you a little.
No, I know.
Time constraints. So our next speaker is Dr. Rajendra Kumar Sharma, Managing Director of Spel Technologies Private Limited. A brief introduction before I invite him for his talk. Dr. Sharma holds a PhD from University of Pune in the area of supercapacitors and its applications. So SPEL is India's first manufacturer of supercapacitors and has expertise in the field of energy storage technology. SPEL has also contributed to an in-house development of activated carbon supercapacitors and is jointly working with over 21 prestigious government research organizations and universities in India as well as outside India. So I'd like to invite Dr. Sharma to give us talk on the CMET battery technology. Please, sir.
Thank you. Good evening, everybody. And in fact, it is nice to see this kind of gathering, scientific community and the industry coming together to understand each other Basically, if you look at our culture and outside India, most of the developed countries, if the industry is having an access to research institute, industry is a big man. It is a big industry. And they always struggle to get in touch with the research institute. Let us come together. Now, coming on to the point, you have witnessed a lot of technologies available for your evaluation, for your understanding, and make it into a business model. Normally, we call it invention. See, all these inventions which has been presented to you, all the research work which has been presented to you, we call it necessity is a mother of invention. But being an industry, I will tell you one thing, frustration is father of innovation. So we have to arrive on something to create a business model, to create a value. Now, out of all these inventions, research presented, I'll be talking about on one invention or one research, or you may call it as a one frustration. What is that frustration? It is energy storage. Nowadays, everybody understand energy storage is the next oil. We are talking about global warming and all those. 2/3 or 75% of the global warming is coming out either from energy generation or energy utilization. So we want to go green, and everybody is talking about the green solutions, the green energy storage solution. That is where the battery comes into the picture. When we talk about battery, people are referring to lithium-ion battery. And see, one statistics I want to share. When we talk about lithium batteries, 70% of the research on lithium battery is either done in India or by Indian. And really it is a mystery. 21 years have passed. Industry has not come forward to manufacture lithium battery in India. Where is the gap? Even in Bollywood, in 20 years, the ghost comes out. 20 साल बाद आ गया. हमारे पास manufacturer नहीं आया. So I'm very much thankful to MIT and vision of Dr. Kale, our secretary of MIT, vision of Dr. Sandeep Chatterjee, all coordination. We have worked out one solution, wherein a tailor-made solution for Indian companies, how to manufacture lithium battery. I'm not talking about a conventional technology transfer. It is not symbolic. We have created a center of excellence. MIT has created a center of excellence with a vision. We want small industries to come out and start manufacturing lithium battery. Industry can very well understand after 21 years, if you are thinking of manufacturing something which has been manufactured which has started 20 years before, we will say all other manufacturers have recovered their capital expenses, right? So how are we going to compete with them? That is the biggest challenge. So what we have done, many times, small people can penetrate. You may not be able to penetrate with a big thing. So MIT has worked out, CIMET has worked out, Center of Excellence, jointly with the industry. And what is the model? I will just try to brief you in short. Say, you must have heard in paper, some company coming out with lithium-ion battery manufacturing. What is the project outlay? 500 crore, 800 crore. People say, forget it is not our cup of tea. So what we have done, coming from capacitor industry, we have applied a very unique model. We have divided this lithium battery manufacturing into 4 parts. And what is this 4 part? See, I will start from the reverse side. There are many people in India who are importing the cells, adding electronics onto that, around 24% of the value addition, and selling it in the market. Fine, it is a business model. But the cells are imported. How about if these people, they get the cells indigenously? Because as an industry, I can understand a pain. When I go to sell my power pack in the market, I need to give a guarantee. But on the cells, I'm not getting a guarantee because these are imported. They are coming from China. And the unique USP, when any technology is at such a level, you have only one USP, price. Nothing else. So how to handle that? So basically, if we get a cell, if we provide a cell to this module manufacturer, that will be a great idea. What is cell manufacturing? Normally, all these companies, they are doing cell manufacturing, but they are doing it from coating level. They make their own electrode. We have a plan. We don't want, we don't have reservation. If somebody wants, they can make their electrodes and cathode. But we can provide a facility wherein you don't have to make your electrode. If that problem is resolved, then definitely we can rope in a small industry wherein a winding machine will be there or stacking machine will be there, input raw material, anode, cathode, separator, packaging material, and electrolyte. That sounds slightly simple. Nothing dependent on technology. Many people come to me, we are not aware of the technology. I tell them, you don't have to. आपको सिर्फ लपेटना है. पहले battery, फिर पैसे. Okay, because that is the business model for industry. So what you need to do, you get the electrode. It hardly matters which chemistry you are getting. Depending on your requirement, all the electrodes, they look alike. All black दिखते हैं. LTO है, LFP है, मुझे नहीं पता. लेना है, machine पे लगाना है, cell बना देना. So that is the model which is there available with us. Now, from where the electrodes are going to come on. First, I will tell you the model which is of cell manufacturing. Everybody is worried about how much investment is there. Roughly within 5 crores, you can do that. Cell manufacturing. It is a small industry. With that, you can do annual business minimum of 10 crore. The rate of return is also perfect. The capital investment portion, MCCIA has supported that. The vision of our secretary and Dr. Sandeep Chatterjee, Dr. Kale, because it is a story of chicken and egg. We want to make lithium battery and we want machine indigenous. Kahan se aayega? Because there are no manufacturers, so machines cannot come. In fact, India is blessed with a very mature mechanical industry, a good electronic industry, but we have to show the way. So we have developed in-house machineries for that. And our machinery is definitely 1/3 of China. So if your capital cost is less, your final product cost is going to come down, because the unique USP which is there in the market for the lithium battery is the price, and we have to be competitive against China. So overall, this particular cell manufactured with this kind of technology, with this kind of thing, the cost will be around 15 to 20% less than China. That is the beauty of the model. Now, coming on to the electrode manufacturing, we have a model for that. Okay, you can put up a unit for electrode manufacturing, technology is available, but then that requires high skill with respect to understanding of technology. But no matter, the cost of this kind of project is anywhere between 10 to 12 crore. And one electrode coating plant can support around 25 winding machines. There comes the cost in between, because if you want to manufacture your own electrode, you will have to put 25 winding machines. Okay, your cost goes up because you have to match the break even. What we feel, first let us walk, then we'll run. Things can be built up in that way. So similarly, this electrode manufacturing module is available. Anybody wants information, they can they are most welcome to CIMET, Center of Excellence. Ministry has been kind enough to build a separate unit, a separate structure of almost both the Center of Excellence, 35,000 square feet. Ministry is supporting on that. We are putting up a simulation center over there. We are putting up a enable aggregated lab over there. This all thing has been tailor-made with respect to small industry, because if you, as a small industry, if I go to somebody, they will ask me, give me test report. If I go to approved laboratory, the cost is around 20 lakhs, 25 lakhs, depending on what test you want to do. So we are putting up a aggregated lab for that also. For the technology was taken from us, they will be given at a very nominal price. Okay. So simulation center, what is that? Suppose if you are manufacturing lithium battery and your customer wants to incorporate that in some other application. You don't know how it will behave. You can give us a parameter, a data sheet of your battery, the parameter of the load. We can simulate that and give you suggestion. That is called, we are doing a hand holding. So this Center of Excellence, unlike, I don't want to be specific, but I can talk about my Center of Excellence, Mighty Center of Excellence. It is not symbolic. Equipment over there is not a museum. Okay, it will be running, it will be producing the cells, and we will be training the manpower also, because industry means me. Maratitla me sotta. When any industry want to rush, they look at only me. Market hai kya? Or environment hai kya? What is environment? Government subsidy. If these two things are satisfied, industry want to rush. Market bhi hai, or environment bhi hai, government is promoting, but we are filling up the other required M. What is that? Method, that is technology. Machines, that support. Material, that support. Manpower training, that support. Of course, after all this, combining all this M, we expect ethics on that. E. Okay. So with this, I will have to sign it off because the time is short, but you are most welcome. And definitely, we would love to support the industry to start manufacturing lithium-ion battery. We are sitting right in Pune, right at the vibrant center, Maratha Chambers of Commerce and Industries. Let us make Pune a hub of energy storage, lithium battery. Thank you.
Thank you, Dr. Sharma. For the last presentation for today, I would like to invite my colleague, Sri Krishna Gadgir. So I'll also introduce him. You have got only about 8 to 10 minutes max. So while he sets up his presentation, I'll just give a brief introduction. You can remove the audio, you can remove it. So Sri Krishna is an engineer and a certified energy auditor by BE and a certified energy specialist from UREM. He has worked in the energy domain for the last 15 years in a managerial roles. And we also have an energy committee at MCCIA, so he has been leading activities of the energy committee, also representing on MERC on behalf of the industries. And since last 2 years, he has been working as the CEO of MECF, that is the MCCIA Electronic Cluster Foundation. And I think it is due to partially start from next month. So I thought, why not Shri Krishna can give some updates about what's happening at MECF. So over to you, Shri Krishna.
What do you say? This is remote.
Okay, good evening all. I am Sri Krishna Rajendra, working as a CEO of MECF. I'll just give a brief about MECF, the journey till now and the future. So, just to give you a brief background about this thing, METI has announced the financial assistance for setting up electronic manufacturing clusters for promoting electronic system design and manufacturing in Maharashtra, and Pune has been declared as brownfield cluster, and through which they are giving some subsidies or some financial assistance for setting up a common facility center. So with this, MCCIA as an industry body took the initiative, and after long deliberation, discussions, taking inputs from technocrats as well as our committee members, electronic committee member, past president, and everybody, we thoroughly discussed the issues. What are the services, what are the industry needs at that particular point of time, what are the future needs of the industry, and based on that we concluded about having some 4 to 5 verticals in this common facility center, and we applied for that common facility center, and with the good offices of MCCIA and other our collaborative industrial association as well as METI, we got the sanction of this project. So let us talk about what is the need of such CFC. CFC is a common facility center. So Government of India is promoting Make in India and other things, and also they are looking at reduction of our dependency, especially in electronic segment, on China and rest of the world. So as you are all aware, actually the basic hardware, there is a lot of dependency of China. So the government is talking about having some manufacturing activity setting up in India, and related to that, they are also looking at such facilities. Then there is a considerable gap between demand and supply with regards to such facilities in and around Pune region. So the industry is looking at a waiting period of say 2 weeks, 3 weeks, or something like that. And also the costs are, I'll not say extravagant, but based on the demand supply gap, definitely the costs are like that way only. So a couple of our industry members have also informed us that it is better to take the test material or test equipment or their test product to Bangalore and get it certified. That will save on their cost as well as time. So there is a substantial need about such facilities in and around Pune region. Then attract investment and in and around Pune region. This is actually the motto why MCCIA is there for last 84 years. So we need to project, or we need to have such facilities or such environment so that the Pune will get maximum investments as compared to rest of the India, I'll say. So unless and until we have such environment or such facilities available, there won't be any investor who is going to come to this region, and this center will definitely add value to this point.
then help startup companies in meeting their testing and certification. So this is the most important thing, because after Bangalore, Pune is hosting a lot many startup companies, and most of the startup companies, they are either IT driven or some machine learning, IoT based, or something like that. So man-machine interface or something like that is essential for their product development and other things. To suffice their needs, they need to undergo lot many processes, and it is absolutely unimaginable for that entrepreneur to have such high-end softwares or high-end test facilities, either to buy or just to wait for 3 weeks, 4 weeks, and something like that. So definitely we are targeting the startup companies also in our center. So also the services services that we will be rendering through this center are affordable and having lesser waiting time as well as turnover time. And the most important thing we are looking at, that we are going to give the training to the young graduate passing out from engineering colleges or the employees of the existing electronic company and other things, because lot many technologies are changing, and those managers are looking forward to train their employees for such new technologies, such new instrumentations and standards. So this is actually the need why MCCIA has took the initiative for setting up this project. So let us talk about the MECF's USPs. So this is one of the biggest CFC approved by METI under EMC scheme, and largest in India. So the other center which has been approved is there at Aurangabad, but they have almost 40 or 35% of what the numbers we are looking at MECF. We are having latest technologies, latest equipments, and also we are looking at to cater the industry requirements in terms of EVs, in terms of 5Gs, in terms of RF, which because these are the things which are what you can say, they are upcoming in the market and they are going to stay for longer time. So we are going to cater those segments also. Then we are adopting pay for use model. So rather than just investing hugely in the softwares or in test equipments, it is a common facility center. So you just come down and get your product tested and pay for that much of amount of time and the equipment what you will be using for that thing. Training, definitely we are going to give the training. We have a couple of discussions with Skill Development Council of India, or because METI is also having their own training programs and certification programs and other things. So we may be collaborating with again to METI or Skillcon for pertaining the training for young graduate as well as the technocrafts. This will be a one-stop solution for from design to certification. So this is the unique thing what my predecessor were thought of. That would be a one-stop solution kind of thing. So the entrepreneur or somebody is having one brilliant idea that he want to see whether that is going to work or not. So just with an idea, he can come down to our premise. He can get his idea 3D printed. He can get it simulated through software and other things. He can do the test and measurement kind of thing. And if at all everything goes well, he can go for the certification part of it. And throughout his journey, he would be assisted by the expert in those fields. For an example, in design vertical also, there would be experts. Those experts would be giving the guidance to the visitor, so that that would be a fruitful kind of activity. Then it is about 27,000 square feet built up area, and it is located in very prime location at Quality Circle, Telco Road. And we are having definitely state of art as we move forward. The building materials and everything, we will be having solar panels and everything. So I'll just give a brief background about what is this project is all about. So this project, this MECF CFC has been promoted by MCCIA, and it has been supported by METI through their grant in aid. The approved grant in aid, what we are looking at from METI is 50 crores. State government also contributing to this noble cause, and they are contributing 6.7 crores as a financial assistance. And as a MCCI, we raised the industry contribution of 10.3 crores. So in all, there is a 67 crore project, but these numbers are right in 2017. And now we are looking at almost 75 to 77 crores. And I really don't know how we are going to absorb that cost escalation, but thank to METI, because they took our application positively, and they are very cooperative in this regard. So there are 5 verticals which has been shown here. So design center, rapid prototyping, and each and every cost has been approved by METI. So there is no deviation and variation in this thing. Test and measurement infrastructure equipment we are going to purchase. Here you can see the number 49.75 crores worth of equipment. But right now that number has gone shoot up to 58 crores due to cost escalation. Exchange rate has been increased from 2017 to 2022. So we are looking at investment in equipment itself roughly about 58 crores. So what are the expectations and deliverables of MECF? So whenever I meet any government officer or any minister or any IAS officer, these are the 3 points they talk about MECF. First and most important point is to provide the services at market competent rate and with lesser turnover time. This is their first expectation from MECF. So definitely we are looking at those things, and as far as my projections goes, we will be fulfilling these requirements. Then it has to be a self-sustaining business model. So I'll just take 2 minutes on this self-sustaining model. And the last point is many industries need to avail these services. So the MIT require higher volumes of industry using such facilities. So I'll just talk about the self-sustaining business model. So to achieve self-sustainability in this business model, what we did, we collaborated with the like-minded industry. Those industries who are there in the market for last many years, we collaborated rather than just investing again in manpower, again in expertise, again in standards. We collaborated with those companies who are there in the market, and through those companies, we are going to provide the services. We call those companies as a operating partner. So this is MECF is a Section 8 company. We are there not for making any profit out of our business, just to serve the industry in and around Pune region. This is our motto. These are the contributing members. As in previous slide I showed you, we have raised 10.3 crores. So these are the industries who have already contributed for this noble cause. Then let us talk about the verticals. So EMI EMC, the operating partner is TUV Rainland, and that EMI EMC will be start operating in November 2022. There are challenges with regards to the man material movement from Germany, Poland, and rest of the world. That's why this project, this anechoic chamber is getting delayed. That is why it has been projected as November 2022. Actually, the building infrastructure and the rest of the things, electrical supply, permissions, NTCV permissions, everything has been done. We are just awaiting to start delivering the services. So test and certification, lot many chambers are there, installed, commissioned, handed over, and we are going to start pre-compliance testing from May 2020. That is from next month itself. Each and every vertical, each and every thing what we will be offering, that would be annually accredited. And for getting the annual accreditation, there is a timelines of say 90 days or something like that. So till that time, we are going to offer pre-compliance part of testing or anything what we are going to do. Then test and measurement vertical, we are expecting to start functioning in May 2022 itself. And in this test and measurement, there are 5G testing, there is a EV battery testing, and the rest of the latest things, those are there. Design center and rapid prototyping, this is also one of the major, what you can say, vertical in our center. And the required simulation softwares and other things, those things we'll be procuring to the industry. So rather than just doing some R&D or practical work at site, it is better that anybody can come to our design center, get their idea or prototype tested, simulated, and other things, so that the expert can give his opinion or suggestions on whether that product or that thing is going to work in the market as per their expectation or not. So this is the beauty of design center. So I'll just show you. I will just show you what are the services which we are going to offer. So just run through the services. These are the services that we will be offering through EMI, EMC and test and EMI, EMC vertical. Then these are the services through test and measurement thing. For test and measurement, we are having 5-ton shaker. So this is also one of the kind installation which in Pune region is having, and 10-meter anechoic chamber that would be built through Franconia. Then these are the services. You can see dry chamber, then high ram chamber, thermal shock chamber. All chambers are there. So the testing IP setup, we are also having IP setup. So IP up to IP68 as per IEC 60529, we are going to test the products. We are in a position to test the products, vibration, mechanical bomb test and everything. So these tests are available. These are the further test, environmental and mechanical test, what we will be rendering through this center. So under test and measurement thing, as you can read, automotive, electrical vehicle charging stations, RF in car, bus coding and diagnosis. Then under RF 5G technologies is various applications, GSM applications, MIMO 3G, 4G applications. All things would be we can do the test and measurement kind of thing. We are also supporting the IoT platforms. Then also we have a calibration center at our end. So any equipment can be calibrated with traceabilities and everything that can be done. Solar simulation monitoring, PCB soldering, SMT line, pre-compliance testing for EMI, EMC. So this thing is also there in this thing. So I'll just briefly talk about the value proposition, what we are going to offer to the member industries. So as previously told to you, we have raised almost 10.3 crores from the industry, and those contributing members, they will be getting such benefit. So for an example, if you are investing like 5 lakhs in MECF, then you will be getting a discount of 15% until the discount is amounting to 10 lakhs. Till that time, you will be entitled to get the discount at this center. And the most what you can say important thing is that the priority allocation, because we are going to commit to you कि within 14 days your product or that services would be available to you. So this is the most important thing. So in this way, we are just requesting all the industry members to have a look at our facility. Anybody is most welcome at our center because it is almost ready. Only IP setup is yet to come, but the testing at that vendor's place has already been done. It just need to ship here and install it. So everybody is most welcome to see the facility and also think over contributing to MECF, because in long run you will be benefiting from such structure in discounts as well as in priority allocation. So I'll just show you the photographs. This is the infrastructure. Forget about infrastructure utility. This is the office area. This is the electrical and safety and reliability lab. This lab is already been set up. Then you can see the drought-proof chamber, endurance test chamber, walk-in chamber. All these chambers are ready, tested, calibrated, and handed over. So these are good to go. We can do the testing in these chambers. Dry chamber, lab sphere. Also, we are having a lab sphere installed in our facility to see the lumens, CRI, and other parameters of the light fittings. This is the simulation view, what the building is exactly looking like. And you are most welcome to contact me on this number or drop an email. And all are requested to visit our facility. And at site, I'll be in a better position to address your issues one-on-one. And looking forward to hearing from you. So thank you, Prashant.
Thanks, Shri Krishna. I think, Dr. Kale, we have got time for 4 to 5 questions, after which we'll shift outside and then we'll continue our interaction over there. So, if anybody has any questions for CMET or Shri Krishna, you can please ask. Yes, sir. Mr. Bua.
I just wanted to understand.
Just take the mic so that everybody can hear.
Thank you. See, I visited some of the sites and TOT sites particularly. And there are good projects, there are good products have been developed by scientists. Thank you. But the thing is that we are not able to understand how much is the investment per se to produce that particular product. For example, if you are saying NTC is being developed, I wanted to understand how much could be the DPR, I mean detailed project report. If it is not DPR, all right, but budgetary indicative pricing of the project. Market size and these all things which we can find it out. That's not a problem. But in order to produce that international standards, whatever IEC standards you might be following, whether it has been followed that as per that standards or not, that we need to understand. And the machinery and that maybe time and these all things which we can find it out. Thank you. This is what my question is. Thank you.
When we are developing technologies, most of the things we include in the technology transfer document. So whatever technology transfer document we prepare, all whatever you mentioned, everything is there in the TOT. At least what are the equipments may be needed or something like that, or your cost of production of what particular scale.
I put it other way around. In fact, it is there in the technology transfer document. If we can get some indicative idea,
okay,
then I will understand. Oh, okay, this is my investment, and then this is likely to be ROI, and then I need to take an informed decision. Yeah. Instead of I putting it, money on the table, first 10 lakhs rupees, and then understanding that this is going to be 100 crores project, then this is not worth. Then I need to understand my capacity also. तसं काही करता येऊ शकेल का?
आता काय तुमची कॅपॅसिटी माहिती असेल मग आम्ही सांगू शकतो.
तसं पण चालेल. This way or that.
Yeah. So a particular capacity, we can tell that this might be the investment.
Namaste. मी Rajendra बोरपडे. I am ex-vice president of Midpoint Consultants. And I am pleased to see here Sri Krishna presenting. पहिला जो auto cluster केला पुण्यामधला that I have done. To Midpoint, I was consultant to develop DPR and got it sanctioned over 45 crores. I think it's working in field break. तर मला सिमेंटला असं सांगायला आवडेल की now I run my own consultancy. Consultancy in engineering services. I am associated with Ministry of Urban Development as well as Ministry of Finance. तर हे जे टेक्नॉलॉजीज आहे असं प्रोजेक्ट मी 2005 साली I was selected by DSIR to bring out technology transfer between India and CIS countries. So I went to Russia, I went to Uzbekistan. A lot of experiences in this field. I carried about 50 different technologies, carrying single person, right from biotechnology to electronics, IT, engineering. So I think we'll meet in person.
Yes.
So that is why I am talking in public, because I carry out feasibility reports. Like his requirement is there. So what is the market? What is the demand supply gap? What is the competition? So I work out at personal level my feasibility reports, which are bankable. And I think if you made something in like technology industry in myself.
Yeah, I think.
And good thing is I am MSc Physics and Electronics.
That's good.
तुम्ही काय करते ते मला थोडं कळतं. तर असं जर आपण वर्कआउट केलं तर I think it is good situation.
तुमची मदत लागू शकते आम्हाला.
हो नक्की. चालेल. आम्हालाही चांगलं पुण्यातच आहे मी. त्याच्यामुळे it will be good for us. Thank you.
Definitely.
तर सगळ्यांनी फायदा घ्यावा म्हणजे इन्स्टिट्यूट.
Yeah, because we have.
Hello sir, I am Mukesh Mali. I have 3 to 4 objective questions.
Yes.
Whom to contact for technology transfer?
Whom to
contact for?
Yeah, we'll give that because our program we have the business development group here. They manage all technologies developed in all centers.
And second one is you mentioned center of excellence. So how to get access for that? And what is the eligibility criteria for incubation?
Incubation at the moment we are not considered. Only startups we have in the center of excellences. If we want to have some particular like Rajendra ji mentioned that when you have a particular like only electrode manufacturing or only powder manufacturing. So you can have startup here, then we can at least for 1 or 2 months you can come there and work out your.
We have startups.
Okay.
We have recognized startups. TPIIT has recognized.
Then you can come and you can join to us with we can have a MOU and all this. No.
And the next one is lithium material technology you have mentioned in this, right? Are you providing the technology or lithium itself?
Technology.
Thank you.
Hello, sir.
Yes.
This is wonderful research efforts which are made by all of you.
Thank you.
Basically, cement has very wonderful calculation facility.
Yes.
Lot of spectroscopy, microscopy are there. Like startups and small industries, they also have their own innovative ideas and all. So, is it possible that this calculation facility be open for startups and?
Yeah, it's open.
Yeah, but what I understood that whatever center excellences faculty in my approach, they consider startups and small scale industry as a bigger industry, and their charges are 90% higher compared to the research scholars and other innovators.
I think for small scale industry we have.
We have three types of charges. One is for R&D. One is for R&D. Another one is for startups, which you have a suppose a certification of small scale industry, and another one is the regular industry. So if you consider regular industry, it's high. But for medium and small scale, it's almost at per government labs like.
Yeah, but it's very less as compared to others.
And if you compare our charges with private or ARI, you will find the difference.
See, we are not doing as a business because we are not like profit maker. So it's just providing services to industry, but industry do not feel that it's very low cost, so maybe some problem. So.
Good evening all. Myself is Rajendra. I'm a solar PV manufacturer basically. Can we start a manufacturing of solar cell in India? Because right now I'm taking the cell from China only. China is the market who is producing the cell and selling the cells.
This is silicon cell.
Yeah. The PV cells basically.
Basically, CEMET is working on not silicon solar cell because silicon solar cell is already established technology. Okay. So only problem is the vapors for the silicon that we have a problem. I think that will be sorted within 6-7 months because some industries are coming up for these vapors. Then absolutely, then we can. It will be available.
But we can give a technology for back and front electrode material.
Yes.
Okay.
Materials technologies are available.
But there are manufacturers in India who say. Yeah. Adani has one very big plant in. I supplied the machine when I was looking.
But they may be importing vapors.
Ingots, they are.
Sales are manufactured.
Actually, not they are importing, and then vapors.
They are just making it, slicing it, and making cells. So purification of silicon, no one takes in India as of now.
That is going to start now.
That is what we are expecting.
So within I think it's 7-8 months.
So 1.5 it is going to
Because it's already now the lined up.
Yes.
Maybe within a few months, something will come.
So my name is Gautam More. I wanted a question directly that since there is such a big thrust for the lithium-ion battery manufacturing that we mentioned, but who will actually assure the supply chain for the lithium in the first place?
Actually, lithium supply chain already we have made. Government has already signed some contracts.
Yes, so does the COE actually take care of that?
Yes.
And is there like a guarantee? Like
we'll give the supplies and all that circular economy we are doing it. No problem.
Are you going to be the procurement channel for the?
No. You have to direct to interact with these companies, which they have
But
signed the
there will be
contract.
security, right? Because
There will be
it
security.
could just go off one day and
No.
you know all these equipments, but probably not be.
No, there will be security. When we are doing that everything will be.
The second part is like all these, like you got your other colleagues in Thrissur and Hyderabad. The problem is like going to them, started developing a channel and everything actually takes a lot of energy.
No, we have our business development.
If you know companies from Pune or our region actually can go to your office and actually make
Yes,
the
definitely.
bridges happen.
Actually, Pune is the headquarter, and we have business group.
Correct.
So they are actually interacting with them, and
So many times they say you go and talk to them in Thrissur, that they are actually.
no, I don't think so. It is
So it
now
can happen
being
from here and
now I'm the head of the three centers.
Right,
So I have to
so
take care.
that's why I'm asking this question.
So it will not happen.
Problems, you know, the people face.
Now almost everything I know, absolutely no problem. So
Thanks.
we'll take care of them. I think you are most welcome to visit our cement laboratories. If you want to visit Hyderabad or Thrissur, if sometimes you are there somewhere in Kerala, you just talk to me. We can make a visit, or in Hyderabad anytime.
Pune facility is here. also.
Yeah, Pune facility you can have.
Right?
No, here.
Panchavati.
Panchavati.
Achha.
Very nearby, near to
Very
university.
near, I'm going to come.
Anytime.
Yeah, your presentation was very impressive. I was not aware that such kind of research is going on. In your presentation, you had made some cell chemistry other than lithium and sodium. Are they worth pursuing?
Yeah, because like you must be talking about lithium sulfur and
No. Your lithium, other than lithium and sodium, you also mentioned some other
potassium ion,
and some
aluminum air and
yeah. Are they worth pursuing? And in your
because worth pursuing because the aluminum air, if it is successful, the aluminum is very cheaper available in the country, and the cost of the aluminum air batteries is much cheaper as compared to others.
But is there any timeline of your because
The timeline is there.
You have mentioned as a future.
No, not future. I'm telling. It is simultaneously going on. See, we have one part is a lithium battery, but other battery work is already going on in the center itself. Like you said, solid state battery, which will take care of
Solid state battery is also part of a lithium battery. It is only
it's a part of battery, lithium-ion battery, but still some problems are in the solid state batteries. So that needs to be solved. Like suppose the solid state electrolyte, which you are talking in the solid state battery, we may have some polymer, we may have some ceramics, we may have some glasses. So where there we are, there are some limitations for glasses, limitation for ceramics, limitation for polymer also. So we need to work out on that for better capacity.
You are working on other cell chemistries also.
Yes. Because center of excellence is for that. We have to see 20 years ahead.
Yeah, 20 years ahead. But 20 years ahead, you think that those other chemistries also will have a good amount of potential.
Sodium ion now we are very close. So I think very 1 or 2 years, I think we launch that also. Sodium ion.
But other cell chemistries also, you are,
yes.
the work is going.
Yes, you can visit and see. Talk to our researchers. And basically additive manufacturing, we are the new area, so you can you are welcome for this.
Sir.
Yes.
Actually, since from last 20 years, we are working on power electronics area.
Yes.
And many of our researchers, they are also working in the same domain of EV. And right now in battery, this alternative fuel technologies.
Yes.
So for that, can we have that type of postdoctoral type of facility from your center? Can we do research for if we do some MOU and like this, and our 1 or 2 members may work with you in association with you? Is it possible?
Is it possible? And before that, you have to sign NDA and all this, because again you will be the part of that system, no?
Yeah.
So we have to sign the NDA and MOU. That is possible.
Okay.
But will not pay these people own. You can come from your own source.
Yeah.
Absolutely no.
Okay, thank you.
I think you already exceeded the time.
Yeah.
So just close with a quick formal vote of thanks to Dr. Kale and the CMET team and Meti, and of course my colleague Shri Krishna. We have dinner waiting for us outside. The conversations can continue over dinner.
So I would like to introduce my scientist.
Oh, sure.
Please stand up.
Yeah.
Dr. Kulkarni, our registrar today with us.
Yeah.
And Registrar Radha Madam, then Program Coordinator, Dr. Tanay Seth, Dr. Rane, who is additive manufacturing. Rane is Kulkarni is working on COE rechargeable batteries. Then sensor person, Dr. Adhyapak. Then Madam, she is working on. She is the unique expertise in LTCC. And we have graphene technologies and 2D materials. Which I mentioned, like quantum materials, and I think somebody is there. Ranjit? Ranjit is not there. Then we have Hawaldar is there. I think they are not. Dr. Sudhir, Govind, they are working on. Dr. Sudhir is working on hydrogen from water and fuel cell technologies, hydrogen storage. So all energy related things we have from solar cell to fuel cell, then hydrogen. So since hydrogen is the future fuel, so we thought that we should have cheaper hydrogen from water. So that is the new technology. We have then quantum materials and quantum technologies. This Ranjit Square, I can say two Ranjits, Ranjit Kashi and Dr. Shinde is working on the solar cells, flexible solar cells, and flexible batteries also we are working. It's a very small team of people. Maybe we are only 30 people. So in the 30 people, we have developed all kind of things in Pune. And thanks to you, because your support is required to us. We are in small numbers. We can take it to the for some stage, but further somebody has to take it. So like Rajendra Sharma is helping us, and we are doing wonderful job. Means we are also enjoying with it. So same thing like I'm expecting in our additive manufacturing. There somebody wants some new ideas also come up with this in the additive manufacturing. If somebody is importing some materials from abroad, whether we would like to indigenize them, because we have state-of-art reverse engineering facility. We can reverse engineer materials and duplicate it, or we can modify it, or we can do better compositions. That already we have done for some many other companies. Like we are working on Moiling Limited, then we are working on Tata Chemicals, then we have now Modison. We have given them the technology for silver paste. So then Eton, Madam was working with Eton. Some of the circuits, piezo sensors and all this. So there are many things we can do for the industry. We may not be knowing that we can't do, but if we can come with some problems, so definitely we can solve the problems. Maybe problem, because we found that some of the problems are very simple. If we analyze like Dr. Jato, डॉक्टर ने डायग्नोसिस केल्याशिवाय आपल्याला उत्तर शोधत नाही, तसं आम्ही डायग्नोसिस करू शकतो आणि चांगला आन्सर देऊ शकतो.
Anyone is interested in RFID, we are working on RFID materials.
Tags, RFID tags. Like and now that also flexible also flexible also.
Because currently they are importing all of it.
Yeah, we can.
We have tested our materials and now we are lagging. We are not expert in the fabrication, but we have a materials.
At what stage that is right now?
You can say, you can visit the listing, you can see the communications. We are able to communicate very well.
We would like to take further. If you are somebody industry is interested, definitely we can club. Same thing also we are putting in the additive manufacturing, because whether this can be done through additive manufacturing.
There are some things displayed outside, so you can have a look at those items as well.
Thank you.
Thank you.
Thank you very
Please
much.
join us for dinner.
Anyway, तुमचं कार्ड किंवा नंबर द्या खरंच वर्कआउट करू
बघतो काय
आपण
Thank you.
हो हो येस येस हो हो येस हॅलो मी तसंच करतोय
श्रीराम sir, working on TFT panels. So, exhibition video.